I'd like to talk some more about 4-wire measurements on the bench where you're using test leads. The first two videos I've done contain some other 4-wire systems, power supply control, remote reading of distant objects. Let's revert back to 4-wire measurements on the bench. This is a 4-wire measurement. I'm using a Hewlett-Packard voltmeter that's set up for 4-wire resistance measurements. These probes are measuring DC potential, or they're carrying DC current. When we're looking at resistance, it's always DC current. I'd like to point out two things for your consideration. One is, where does a 4-wire measurement become a 2-wire measurement? Well, this is 4 wires. This is 2 wires. This is the unknown resistor. So we're measuring 4 wires to these 2 points, and the 4-wire measurement becomes a 2-wire measurement from these 2 points to the device under test. Now, the whole reason for using 4 wires is to make the test eliminate any undesired resistance measurements. So it would make sense if these were moved as tightly up against the unknown device as is possible, in order to minimize the length of the 2-wire device measurement. And this is a fairly inconvenient setup. I have to connect 4 wires, and I have to get them as close to the unknown device as possible. In one of the previous videos, I showed how these could be used to replace two wires. So the connection can be made very closely to the device under test. And instead of having some electrical separation between these two connection points, with the clamp, the only electrical separation is the diameter of the wire. So when does a 4-wire measurement become a 2-wire measurement? Keep that in mind. So this is a LCR meter. It's capable of measuring values of inductance, capacitance, and or resistance simultaneously or individually. And in order to do that, it uses an exciting current that's alternating current. Up to now, on this bench, we've used DC current for excitation. But because we're measuring characteristics of impedance, inductance, and capacitance, we have to use AC. I'm going to turn this thing on. And if you want to see how this thing operates, what the buttons do, it's all over YouTube. In fact, a very good teardown was done a number of years ago, 8 or so, by on the EEV blog, Dave Jones. So power this thing up, and it goes through a self-test. And among other things, it's an auto-ranging LCR meter, although it can be set for inductance, capacitance, resistance. There we are. Forget about everything else but the number 1 kilohertz. That's the frequency used to make the measurement. And we can vary that frequency. 10 kilohertz, 100 kilohertz. Now, 100 kilohertz is beginning to be radio wave. It's what's considered very low frequency. 100 hertz and 120 hertz. 120 hertz is double the power line distribution frequency here in the United States. So if we want to see the characteristics of a capacitor or inductor that's used in a full wave power supply, we use 120 hertz. But other frequencies are available. This is capable of 2-wire or 4-wire measurements. If I plug a set of standard test leads in here with points on one end and a banana plug on the other, plug goes in here, that becomes a 2-wire measurement. If I plug something in here, it could be a 2-wire measurement external to the meter. It's a 4-wire measurement inside the meter. I'll explain to you how that happens in a minute. Because we're using RF or AC, the positioning of the leads relative to each other becomes important. So to minimize that effect of having some capacitive coupling between the lead and some inductance based on the length of the lead, we will guard the leads. Guarding means shielding. To shield is the same as to guard. So in either one of these connections, the shields and the wires are brought together and connected here. The far end of the wire, the shields or guards, are left unterminated. Most of these simpler LCR meters, the guard connection is merely ground. On some of them, the guard is actually fed a tiny bit of the RF that's used to make the measurements. So in the LCR world measurement, it's called a guard, but most people call it a shield. The other feature that gives away the fact that it's a more complicated measurement is the fact that there's a calibration system. Calibration is done with the leads open, the lead shorted, and the lead characteristics is stored in the machine. You don't see a calibration button on a VOM, even a 4-wire device. But on something like this, where not only resistance but inductance and capacitance of the lead system needs to be ignored, the calibration button. And of course the leads have to be in place. The leads that you're using have to be in place. Now I'm going to tear this apart and give you a view of what happens internally, mechanically, with these connection devices. I've opened up the LCR meter. I wanted to show you the connections. These are the connections where the double-sided PC boards. Enter. See, they're pushing them apart. So, although this is a 4-wire device, with this being a shield or guard, the wires are 1, 2, 3, 4. Well, right now, they're being connected together. So unless I insert something in here to spread these apart, this is a 2-wire system. Now the banana jacks are actually split. See that vertical split? And do that, you'll see there's one down there. Now that's not to insert a split banana plug. It merely would be the termination of the 4-wire system, turning it into a 2-wire system. Sort of a moot point, because as long as these are connected together, and they are, but let's turn it over, remembering that this is the guard or the shield terminal. So these 4 solder blobs are holding the phosphor bronze connectors, spring connections to the circuit board. And they're all 4 in the ground plane. See the stitching? And it continues up to this banana jack, which is split to 2 halves, but both halves are connected to the ground plane. Here, though, are the measurement jacks. In that case, the 4 blobs holding the spring connector are not connected together. They're all 4 individually done. So in this case, or in this case, where we have our spring together connectors, each one of them has 2 solder blobs, times 2 makes 4. So these 2 blobs are connected to 1 piece of phosphor. There's no connection here. This connection goes out to here, which is another split banana jack. These 2 are connected together and continue down to this half of the banana jack. So as it sits right now, it's going to be a 2-wire measuring system. It only becomes a 4-wire measuring system whenever I intercept this connection, break it with a double-sided PC board, and I'll show you the other side, the live side. Got to be careful not to stretch my battery lead. So now it's a 4-wire connection, this being 2 of the 4 wires. Now it's a 2-wire connection. So to use this as a 4-wire device, it's got to be via these 2 or 4 connections.